Kids, we today, or at least right now, are going to talk about some basic stuff with waves. Okay, so we're going to talk about some wave basic stuff. So let's talk a little bit about it. Okay, so first, definition of wave. Wave is just a disturbance that moves energy from one place to another. Just be careful because some people think, or they have this misconception that when you're moving, the wave is moving along, the medium moves along with it. Remember, what is the medium? The medium is what the wave is traveling through. Okay, here's the example I like to use in class as far as why that doesn't make sense that the medium would move. Think about doing the wave at a football game, for example. Well, if the medium moved, that would mean instead of just going you'd also be going and be moving along. You know, it'd be like, hey, I got lousy seats, let's do the wave. And then, hey, I got good seats, I'm stopping doing that. Doesn't happen, okay? The energy moves through, the medium doesn't really move. What is the medium? The thing is what the wave travels through. Something that's really important you guys understand is the only way to change the speed is to change the medium. So if I talk like this, like la 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 la, I'm not changing the medium, okay? Because the medium is still the air. So like if I was to use our handy-dandy wave equation, okay, if you think about this, well, when I talk like this, that's staying the same. I'm not changing the medium. But I definitely am increasing the frequency. It's more, it's higher pitch, right? Frequency is related to pitch. Well, if this goes up, this has to go down in order to keep that the same, okay? Versus if I do something like,
if I do something like this where I've just, sucked in some helium,
then what I've actually done there is I've changed the medium. Okay, and it should make sense. Sound it's gonna be easier for the sound to travel through helium than it is regular air. Why? Helium, the particles are moving faster. They're less dense. So they're gonna move faster. So that means this is actually going to be higher. Okay, and I was trying to talk just like I normally would talk. And you may or may not be aware of this, but your normal wavelength comes from your vocal cords. So I wasn't doing anything with that. So that had to be the same. So therefore, the reason I sounded like a chipmunk is because if this goes up, this stays the same, then that has to go up. That kind of makes sense. So let's talk a little bit about, make sure you guys understand what frequency actually is, what wavelength actually is, stuff like that, amplitude, that stuff. Frequency, okay, just like when we did our circular motion unit, it's called frequency because it's how often a wave, in this case, is made. So like frequency, the definition is going to be the number of waves per the time. Okay, so if we say you have a tuning fork and it's a 320 hertz tuning fork, what that actually means is it is going back and forth 320 times a second. Okay, so that's what frequency is. Again, it shouldn't be something you have to memorize. Just think about it, understand it. It's how frequent it happens. Okay, wavelength, surprisingly, this is really tricky here. This is probably why you're watching the video, because you're confused about wavelength. Wavelength is, surprise, surprise, how long the wave is. So if I draw a longitude, that's not longitudinal, is it? If I draw a transverse wave here, if I wanted to measure wavelength, it would be from there to there is a wavelength. Or if I wanted to, I could go from here to here. That distance is the same distance. It's going to be a wavelength. Okay, wavelength, just how long the wave is. If I had a longitudinal wave, so let's say slinky, slinky, slinky. Okay, my wavelength would just be from. It could be, for example, the smush part to the next smush part. It could be from the stretched out part to the next stretched out part. That would be my wavelength. Okay. The one thing I do want to caution you guys about, okay, because this is a little bit of a common misconception, is that people sometimes get confused between this and this. One of the things you guys were going to do in class, or at least you're going to watch people do in classes, you're going to use slinkies, and you're going to move your hand back and forth, kind of slow versus really fast. And some people think, oh, geez, I'm moving my hand back and forth really fast. I'm increasing the speed. No, you're actually increasing the frequency because you're making more waves per time. As long as you don't change the slinky, you're not changing the medium, therefore you're not changing the speed. So just be careful with that, okay? Frequency is how frequent the wave is. Speed is literally how fast that wave moves along, okay? So like when I'm talking, my sound waves are moving along at the speed of sound, which is roughly 700 miles an hour, okay? What else do I need to talk about? Oh, interference, that's another basic thing. So let's talk about that. This, again, guys, don't make this more difficult than it is. Okay, if I have this and this, as they pass through, and remember waves always pass through, okay, they don't bounce off, they pass through. But as they pass through each other, I'm going to get a big blip, okay? Or this is A, B, this would be A plus B. Well, guess what? I have just added up my amplitude. I have constructed a bigger amplitude. Hence why it's called constructive interference. So this would be constructive interference. I will tell you guys, I'm not really sure why, but you can expect you're going to see one of these on your AP test. The College Board loves to do these type of questions, okay? Where they go, hey, I have this weird square pulse meeting this weird triangle pulse or something like it. As they pass through, what's going to happen? And don't make it harder than it is. Just literally superimpose. That's why it's called the principal superposition. Superimpose this on top of this. So if I draw my square, okay, and then on top of that I draw my triangle, that's what I get as they pass through. Constructive interference. Very nice. Thank you. That's versus if I have something like this. So that's constructive interference. This would be destructive interference. Okay? Why? I know it's crazy. Like, as they pass through, the amplitudes are going to destroy each other. Hence why it's called destructive interference. So, like, again, it shouldn't be something you have to memorize. Just think about it. It makes logical sense. But as they're passing through, if they're exactly the same size, exactly the same shape, you're going to get nothing. Okay, if we're talking about sound, that would be quiet. If you have ever heard of like noise canceling headphones, that's what they do. They hear the ambient sound and they actually make a sound that cancels it out. Destructive interference. But if we do the College Board's favorite type of question, which again, I'm not really sure why they love this question so much. Here, let's do it so that I made my triangle bigger amplitude than the rectangle. Again, just superimpose them. Okay, so if I decide I want to start with the little square rectangle thing, and then I'm going to draw this right on top of it. There it is. And then that's what it would look like. Okay, that's it. Don't make it harder than it is. So that would be principal superposition with that. Constructive, destructive, and if you need help with the other one, which was Doppler Effect, for that one, I have that other video, so watch that. Bye, kids!